All right, welcome back from spring break. It's a beautiful day for iPhone applications. So today has absolutely nothing to do with Angry Birds. I just thought that starting with that would make today seem much more fun. But it is about iOS and about continuing last week's conversation about introducing this coming month's project, which will be your first of two iOS-based applications. I'll try, since it's been a couple of weeks, for some, a couple more weeks, I'll try to pepper the group here with some questions so that we can all get back onto the same page as to what some of the concepts are that we've been exploring, as well as what some of the new ideas for today and onward are. So without further ado, we're back in this MVC world. And MVC stands, of course, for Model View Controller. But in English, in a sentence or so, what does that actually mean? Okay. +1 for me. Carl.
So MVC is like this paradigm where you can separate out the logic for what you see and your business logic for controlling stuff and your data.
OK, good. So it's this paradigm for designing software in such a way that you separate your views, your controllers, and your models, which are defined respectively as the aesthetics, or the views. The models are your databases or just your data sets. Even though we used MySQL or the like for previous projects, realize that model can really model anything. It can be an XML file, it can be a CSV file, it can just be some generic data that's hard-coded, but it provides the abstraction that your data is coming from this real-world entity or this representation of some data source. And then finally, the controller is sort of the brains behind the whole operation that talks to the models to get some data and then pushes that same data or some transformation thereof to the view. So he's kind of the middleman. And generally, you should not cross these boundaries. So this is taken from Apple's own documentation. And you'll see different depictions of MVC on the internet depending on the language and the context. And sometimes you will see lines connecting view to model. But generally, that's a bad thing. Generally, all communications should be routed through the more intelligent arbiter known as the controller. So if you're writing code, henceforth, especially in iOS, where you have a view that's talking directly to a model or vice versa, that's probably not the best design. Rather, the controller should be asking for data from the model and then passing it into the view, as this topology here suggests. So try to keep that in mind, and we'll try to provide feedback if we see otherwise during weekly, every few weeks design reviews. So where did we leave off? So we started last week playing with some actual iOS code, and you launch Xcode. This here is version 4.3.1. The Project 2 specification will make crystal clear exactly what software you should have on your computer so that you don't accidentally start using some old version, your code doesn't work and the like, so do read that carefully. But here are the templates with which we can begin. So just sanity check. What are these templates exactly? What are these various types of applications you can apparently create? What is it we're choosing here? Zach.
Different slates that give you different frameworks, not frameworks, but kind of template code.
OK. Yeah, so it's just essentially default sample code that you can start with. They're not so much clean slate since they do actually have code in them, but it essentially means that Apple started with the most minimalist template, which is generally considered empty application, or even something more minimal than that, and just packaged up some code, some nib files, the UI mechanisms, that collectively might help you get started writing more interesting apps more quickly. So today, we'll start off with the single view application. And this one's interesting because it actually does give us that MVC framework right out of the box. So if I go ahead and click on this, I can choose, as last time, a product name like demo. Company identifier should just be most anything unique. So flipping around someone's domain name that you own is typically standard practice. We can leave class prefix blank. We'll use iPhone just because it tends to fit on the screen and the projector a little bit better. Storyboards we'll wave our hands at for now. But the second box, use automatic reference counting, absolutely check this. This is this new fancy feature of the latest version of iOS that Apple introduced last summer, and it will make your lives easier. If you struggled with things like malloc and free in a C-based course, realize that these details are now largely hidden from you, at least the free side of things. But in a week or two, we'll peel back this layer and talk about what's actually happening, since this notion of automatic reference counting is used in other languages that you yourself might have used. And unit tests we'll start checking, but we'll talk about those in a week or two. Unit tests are classes that you can implement that test other classes that you wrote, so that if you make some change or your partner makes some change, you have some mechanism already written by you to make sure that he or she didn't just break your entire project because he or she introduced some bug that causes one of your own tests to fail. So I'll go ahead and click Next. I'm going to go ahead for now and just save it wherever. On my desktop is fine. And voila, we have this nice little confusing interface here. So the only thing that's important for now is to take away from this very simple template the flow of what code is talking to what, so that when you guys sit down to dive into project 2, you actually have a sense of what you should change, where you should begin, and so forth. So let's just expand some of these folders real fast. And there's a whole lot of stuff here, but recall 2 weeks ago we essentially said ignore many of these, or at least most of these. But a quick tour back through this. Let's see if we can slide over. Projector's not quite cooperating. There we go. Let's start up here. Main.m. When in doubt, start with the file that's at least most familiar. So what kind of code should you be writing in main.m? OK, good. So none, right? So for the most part, this is the function. Now main is in main.m. Kickstarts the whole process. And to whom does main effectively hand off control of an iOS app? So an app delegate, which is sort of a generic term describing the notion of a guy who's in charge of an application. So it's it's a class to whom you delegate control. And where is this coming from? Well, it's a little cryptic here, but syntactically. But argc and argv are familiar. We can ignore nil, which is essentially like null for now. But this fourth argument to UI application main is essentially informing this class, this function that's called UI application main, to whom control should now be handed off. What file should now take over this application? So app delegate is actually the name of a class. The keyword class is a message that we're passing into that class, which is to say that class, C-L-A-S-S here, is a class method or an instance method. So it's a class method. Why do we know it's a class method? And apologies for the confusion of the names here, that we're talking about a class that's also a class method. Why do you know it's a class method? Exactly. There's no instance. We didn't call alloc, which means we didn't allocate a class, which means we must be passing a message to just the class name itself. So alloc is a class method. Class happens to be a class method, and you can perhaps guess, what does it return? So it returns a representation of that class that you can then pass to another function, NSString from class, which is going to convert app delegate to quote unquote app delegate. Now, why the heck did we just jump through all these hoops when we could have just hard coded quote unquote app delegate? It's a little more generic way of doing this. So for now, though, you can ignore what's going on in main.m, because all that matters is that control has now been passed off to appdelegate.hn.m. Yeah?
Why is the function called here in sort of the C form for rather than Objective-C?
So Objective-C is a proper superset of C, which means it still starts off in procedural style using a traditional main method. The OO layer was added on top of C. Good question. All right, so let's turn our attention now to appdelegate.h. So when in doubt as to what's going on with something, generally I would start with the .h file before diving into the .m file. But let's see what's now in this file. So all of this is boilerplate code that we were given. So what's interesting here? Well, what does uikit.h refer to? What's likely inside of that file? Yeah, so declarations, so C-style declarations of things like UI button, UI view, UI slider, UI ... a whole bunch of UI mechanisms that we started to see 2 weeks ago in the WYSIWYG editor that let us drag and drop things like buttons. All right, let's skip the second line for now. At interface app delegate, UI responder, and so forth. Someone want to translate that one line into slightly less technical English? What is that line doing? Yeah. Okay, UI, close. Flip your story around a little bit.
UI application delegate will implement all the features.
Flip the other possible way.
All right, never mind.
Okay. Someone want to tweak? You're on the right track. Just got the order reversed. Yeah.
So
Yellow.
app delegate implements the features in UI application. That's good.
Good. OK, so app delegate is the class we are declaring in this file. It descends from UI responder, which is apparently some class that Apple wrote that presumably has something to do with responding to UI stuff, touches and drags and presses and so forth. And the angled brackets there denotes a protocol, aka interface in PHP or Java, and this has declared in it some methods, foobar and baz, and the fact that there is this angled bracket notation here says that this class, appdelegate, that we are implementing promises to implement the methods that are declared in that protocol, aka interface. So essentially read it left to right. I'm declaring this, it descends from this, and also I will implement these additional methods that are presumably not in the parent class. That's why I'm specifying them as a protocol. All right, any questions? Well, let's close the declaration. At end just means end of that. So now let's look inside of the class. These two things. So what is a property in Objective-C? What's a property? And what's its relationship, say, with an instance variable? Yeah?
So a property, like, it's some sort of way of like containing the data so you can control how it's accessed and how it's utilized.
OK.
You could, let's say, just put an atomic access, so it has to be all done at one time.
OK, good.
While checking your data and doing all sorts of other things.
OK, good. So to summarize for camera here, a property is essentially like a wrapper for an instance variable. And an instance variable, meanwhile, is a piece of data that's inside of some object. And it's a wrapper in the sense that you can control how that piece of data is accessed and also set by way of the creation of things that are generally called getters and setters, or accessors and mutators, which no one really says, but every textbook says it. Yeah, Jason.
You can also use dot notation.
Yes, so this is another compelling feature syntactically of properties, is that it allows you to start using dot notation. So that if you want to access some member bar of an object foo, normally you would say something like this, or rather, oops, that's the method syntax. If we say foo arrow bar, sort of C style, this would get us the instance variable called bar. But the fact that we now have properties means we can slightly simplify this to foo.bar, which is not a huge leap. You're saving one keystroke, which isn't all that compelling. But when you call it this way, what are you inducing when you access bar in this way? Jason?
You're essentially doing a message, so whether it's getting or setting.
Good. So you're actually invoking the method. You're passing a message known as bar to this, which is invoking the getter in this case. Or if we happen to have an equal sign over here, then you're invoking the setter. And the setter, by convention, has to be called what? For an example like this.
Set and then uppercase of the instance variable name.
Set bar. So this is a convention in Objective-C. And you can override these defaults, but generally this means your getter should be called bar and your setter should be called set bar. All right, so back to the story at hand. So we now have two properties here. One is called window, one is called UI controller. So let's take a look at this one. UI window just refers essentially to the rectangular glass. So in this template, you have some pre-configured code and a pre-configured nib, an XIB file, which is the user interface. And somehow Apple has pre-configured you with a pointer called window that's apparently going to point to the actual window on the screen so that you can actually control it and put stuff there. Strong and non-atomic will come back to strong, but this somehow relates for now to pointers. Non-atomic just means that you're not writing multi-threaded code here. If you actually said that this is an atomic property, Apple or Xcode would add some additional source code to the getters and setters so that you're accessing this variable bar or window atomically. And long story short, that's just not necessary. And if you haven't taken 161 or 61 and aren't quite familiar with atomicity or threading, don't worry, we'll come back to that, but not in much detail in this class. All right, and how about this one here? View controller. What is a view controller? Yeah, Dan. Good, very good. It controls the view. All right, so what does that really mean? So this is the C in MVC. Apple slightly confusingly calls these things view controllers, but it's just controller, really, but specifically a controller that's designed to operate on a view. And this pointer is going to be the mechanism via which the app delegate, recall, which is the class that at this moment in the story is in charge of the application, is somehow going to further pass control of the application onto code that you wrote. So this is an oversimplification, but generally you won't write much code in your app delegate. Most of the code that you write, certainly for Project 2, will be isolated to your own view controllers, your own models. It's the app delegate that ultimately hands control off to something that you really have written yourself. And that's an oversimplification in that we'll see in a second. There are some methods in app delegate that you yourself might want to implement, but those relate to things like backgrounding and force quitting and the ability to actually save really important state before the user hits the home button or turns off the phone or something along those lines. So any questions about this M file? Do speak up. No dumb questions. If you're confused now, the rest of the class is not going to be that useful. Anything at all? All right, so in the M file, thankfully, it's mostly comments. All right, let me close this window on the right-hand side. All the green is comments, but these are the methods. We'll call them stubs. Stubs in that they're really just placeholders that you can delete entirely or start filling in these blanks. And these fairly long-named methods are things you can implement that, again, implement some low-level iOS functionality. How to handle backgrounding, how to handle forced termination. What's nice about iOS is that it allows you, the dev, a last-minute opportunity to quickly save state, to quickly close a database connection, any maintenance